Welcome back to AI.Code.Cast. Today we're doing a deep dive into the count and say problem.
Yeah.
It's a classic coding problem that can really,
It-
make you think. Basically, it's about generating a sequence of strings. And each string kind of describes the one that came before it.
I think what's really interesting about this is how it kind of brings together like pattern recognition and recursion. You're basically building a chain of these descriptions where each link like totally depends on the one before it.
So let's break down how this whole count and say sequence actually works. Because we start off with one.
Right.
And then to get the next string in the sequence, we basically say what we see. So that's 1, 1, or, written out as 11.
Exactly. And then to get the third term, we say what we see in 11, which is 2 ones, or 21.
And this just keeps going on and on and on, right? So 21 becomes 1, 2, 1, 1, written as 12, 11.
Yeah.
Have you ever encountered a sequence like this before? It's kind of like a, secret code.
Yeah, it is. It's like the key to the code is hidden in the previous message.
Yeah, exactly. And, that's where it gets kind of interesting from a coding perspective.
Mm-hmm.
Like, how do we translate this simple pattern into an efficient code?
Right.
I could already see how this could get tricky.
Yeah.
Like, my brain just wants to jump into a brute force way of doing it, just like loop through the string and count all the characters. But I have a feeling that might not be the best way to go.
Yeah.
Especially if we have to generate terms that are way down the line in the sequence.
You're right to be cautious about that. Brute force might work okay for the first few terms,
Right.
but it gets really inefficient quickly.
Yeah.
Like, imagine trying to count and describe the patterns in, say, like the 100th term of the sequence. You would be creating and discarding so many strings along the way.
Oh, yeah.
And that's going to cause some major performance issues.
So brute force is out. What are some better ways to do this then? What if we want to, avoid those performance traps?
Well, there are definitely some more elegant approaches out there.
Okay.
Let's just think about what we're doing here. We're going through the string, we're finding groups of digits that are the same, and then we're describing those groups. Any thoughts on how to make that better?
Well, if we're already going through the string, maybe we could use something like a string builder so that the manipulation of the string is more efficient.
Okay.
Instead of making new strings all the time, we could just change one string over and over.
I think you're on the right track. Using a string builder would definitely help us avoid that problem of creating and destroying strings all the time. It's like building a house, brick by brick, instead of trying to put together walls that are already built.
Okay, I like that. So let's say we are going to use a string builder. How do we actually go about making the count and say sequence?
Well, we could start off with a loop.
Okay.
And this loop would run for n1 times, where n is like the term we're trying to find.
Okay.
And in each loop, we look at the current term, which in the beginning is just 1.
Got it. So we're looping through each term, but how do we take that term and make the next one?
So we need to keep track of which digit we're looking at right now and how many times we see it in a row. So for example, if our current term is 11, we would note that there are 2 ones.
Ah, I see. And then we just add that information to the string builder.
Exactly. Then we go to the next digit and do the same thing again.
Okay.
So when we reach the end of the current term, the string builder has the next one ready to go.
That's starting to make sense.
Oh,
But you mentioned another approach earlier, something about regular expressions. Could we use that here?
yeah, you have a good memory. Regular expressions are super powerful when you need to match patterns.
Right.
And this count and say problem is all about finding those patterns in the strings.
Okay, I'll admit, regex can be a little intimidating. It's like all these symbols and it gets confusing. Could you break it down for us, like how we could use it here?
Of course. So think of regex as a way to define a search pattern.
Okay.
We can make a specific regex pattern that looks for groups of the same digits that are right next to each other in our string.
So we don't have to count the characters ourselves.
Yes.
The regex engine does it for us.
Yes, exactly. And because regex engines are specifically designed for this kind of matching, it can be a really efficient way to do it.
All right, you got me curious. What does this magical regex look like?
It looks like this.
Okay.
1. I know it looks kind of strange, but each part of it has a specific meaning.
Okay, let's break it down then. What are the parentheses for?
The parentheses are called a capturing group. It's like putting a label on a specific part of the pattern that we want to look at later. And in this case, the dot inside means match any character.
So we're capturing any single digit. What about that backslash and number? That's where I really get lost.
That's called a back reference. Everyone basically means match the same character that we got in the first group. So if the first one was a 2, then it would look for another 2.
Ah, okay. So we capture a digit, and then use the back reference to make sure we only match the same digit over and over again. What about the asterisk at the end?
The asterisk is called a quantifier, and it means match the thing before it 0 or more times. In this case, it means match 0 or more of the same character that we captured before.
Oh, so that's how we handle the cases where there are multiple digits in a row, like 111 or 3333.
Ah,
That's pretty cool.
it is. The Regex engine does all the hard work of finding and grouping the repeating digits for us. Then all we do is take that information and use it to build the next term.
Okay, I'm liking this regex approach. So now we have two ways to solve this problem. We have the string builder way and the regex way. I'm curious to see how they work in practice. But before we do that, maybe we should compare the two approaches a little more. What are the good and bad things about each one?
Well, like we were saying, the Regex solution is usually shorter and can be faster, especially if you have really long strings. It uses like these special tools for matching patterns.
It's like taking a shortcut, but
Right.
you got to know where you're going.
Exactly. The iterative way is probably easier to understand if you're just starting out with coding. Or if you haven't used regular expressions much before, it's like all laid out and each step is easy to see.
It's like taking the scenic route. You get to see more of the logic behind it. I'd love to see how these approaches actually work in code, or at least like some pseudocode. Can you walk us through how we would write these solutions?
Sure. Let's start with the string builder one. Imagine we have a function called count_, say.
Okay.
This function takes an integer n as input. That tells us which term we want to find.
So our function knows like what term we are aiming for. Then what?
First, we do the base case. If n is 1, we just return 1 because that's the beginning of the sequence.
Right, that makes sense. That's like the easy one. But what if it's bigger than 1?
That's when we use iteration. We make a variable, let's call it current term, and we set it to 1. This will hold the term we're working with.
Okay.
Okay.
So we start with 1 and build up from there. How do we make the next term?
We use a loop that runs n1 times because we already have the first one. So we only need n1 more. Inside this loop, we use our string builder.
Okay. I can see the loop going, making the sequence. What happens in each loop?
So here's where we use the string builder. We make a string builder object, which is like what we talked about before, for handling strings.
Right, our brick-by-brick method.
Exactly. Now we go through each character in the current term string. We need another loop for this. We can have a variable current char to hold the character we're looking at, and a count variable to keep track of how many times we see it.
Got it. So we're scanning the current term one character at a time, keeping track of everything.
Right. Now, as we go through the string, we check if the character we're looking at is the same as the current char we saved. If they're the same, we increase the count. But if they're different,
That means we've hit a new group of digits. What do we do then?
you got it. We add the current value of count and current char to our string builder. Then we reset the count to 1 and change current char to the new character.
So if we were looking at the string 11221, we would see 1 first, increase the count to 2, then hit 2, add 21 to the string builder, reset the count, and keep going.
Exactly. We keep doing this until we've gone through the whole current term string.
And when we're done, the string builder has the next term ready, right?
That's right. We update the current term variable with the string from the string builder, and then the loop continues. This happens until we've done n1 iterations.
And in the end, the current term holds the nth term, the one we were looking for. That's pretty cool. How about the regex way? What would that pseudocode be like?
For the regex solution, we'd still have the count_say function taking an integer n. We'd handle the base case the same way, returning 1.
All right, same setup so far. What changes when n is bigger than 1?
Well, instead of those nested loops and a string builder, we use our regex, 1, and a loop that goes n1 times. Inside each loop, we apply the regex to the current term to find all the matches.
So if our term is 1211, our regex would find 11, 2, and 11. What do we do with these matches?
We loop through each one, figure out which character it got and how long the match is. The length tells us how many times the character repeats.
So for 11, we get the character 1, and a length of 2, meaning 2 ones.
You got it. We take 21 and add it to our output string. After we're done with all the matches, we have the next term in our count_say sequence.
Wow, that is much shorter than the other way. It's pretty amazing how regex makes things simpler. But I guess if you don't know regex, it might seem like magic.
Yeah, regex can be a little tricky to learn, but once you get the basics, it's a really powerful tool for any coder.
Well, speaking of understanding things, maybe we should step back and look at the bigger picture. We've gone through both approaches, but what are the main things to remember? Which one would you choose in real life?
That's a really good question. And to be honest, it depends. If you really need speed and you're comfortable with regex, then that might be the better choice. But if you want your code to be easy to read and understand, especially if you're working with others who might not know regex that well,
Right.
then the iterative way could be better.
So it's like picking the right tool for the job, thinking about how fast it is, how easy to read it is, and what your team is comfortable with. But before we finish up, I'm kind of curious, are there any like real world situations where this count and say pattern actually shows up? It seems pretty abstract.
You'd be surprised. Like, think about those algorithms for compressing data.
Oh, yeah.
They work by finding and encoding repeating patterns, just like what we're doing here. And if you really think about it, you might even find similar patterns in genetics, where DNA sequences can have these repeating structures.
Wow, that's really cool.
Yeah.
It makes you realize that even these coding puzzles can be connected to real-world problems.
Uh-huh.
It makes you wonder, like, what other hidden patterns are out there.
Exactly. And that's what makes coding so interesting. It's not just about telling a computer what to do, it's about finding patterns and solving puzzles and using that to understand the world.
That's a great way to put it. So to wrap up our deep dive into the count and say sequence, we talked about two different ways to solve it. The iterative solution with the string builder and the super cool regex solution. We saw how they work, talked about their pros and cons, and even went through some pseudocode to see how it could be implemented.
And we also talked about how important it is to choose the right tool for the job, thinking
Yeah.
about things like speed, readability, and what our team knows.
Right. And we even found some really interesting real-world applications showing us that even the most abstract coding problems can be linked to really cool fields like data compression and genetics. I hope you'll all go out and explore these connections more.
I agree. There's always something new to learn in coding.
Big thanks to everyone for joining us on this deep dive into the count and say problem. We'll be back soon with another exciting coding challenge. Until then, happy coding.